Okay, this one's for numbers 12 through 14. On these problems here, you were given a trig ratio and what quadrant that it fell in, and you were asked to find another trig ratio from that information. So the key there was to draw a triangle on your coordinate plane. I've got a little note here to be sure that you watch your signs because you're going to have some negative values on your triangle. Let's look at the first one here. Notice it tells me that you were in quadrant 2 and the cosine of your angle was -3/5. So again, let's draw a triangle for that. Okay, so I'm in quadrant 2. All right, remember when I draw my triangles here, I draw out the hypotenuse first, and then I always form my right angle with the x-axis, never with the y-axis. And then my theta angle is at the origin. So now we're given here the cosine of theta is -3/5. So we'll call cosine is adjacent over hypotenuse. We can write out our little mnemonic here if we need to. Cosine is adjacent over hypotenuse. So this is the adjacent side, and this is the hypotenuse. Now, the hypotenuse is never negative, so the negative is going to go on to the 3. And that makes sense here with adjacent over hypotenuse, that this would be -3, and this would be 5. Now, we could do the Pythagorean theorem here, and by the Pythagorean theorem, this is a nice triple here, that this would be 4. Okay, I could just say -3 squared plus b squared equals 5 squared, and find that that would be 4. So now, let's find the sine of theta. So sine now is opposite over hypotenuse. So opposite 4, and then the hypotenuse there is 5. So it's just 4/5. Now, number 13 was very similar. And on number 13, we were given the cotangent ratio. We were in quadrant 3, and we had to find the cosine ratio. So let's draw the angle in quadrant 3 first. So draw an angle out to the quadrant, or the third quadrant, and then form a right angle with the x-axis. And then theta is the angle formed at the origin. Now, I don't really know my cotangent ratios here, but what I do know is my tangent ratio. I know that my tangent ratio is opposite over adjacent. So if cotangent here is 4/3, then the tangent ratio, that would just be the reciprocal 3/4. And now I can remember that my tangent ratio is opposite over adjacent. So opposite and adjacent here would be 3 and then 4. Now, take a look at that. Again, this is why we say you always be careful with the signs here. This is +3 and +4, but yet this is going to the left 4 and down 3, which makes both of those negative. And both of those being negative is why it's positive right here. So those were negatives on that, and that's where the majority of the people who missed this problem missed it. It was because of those signs there. Now this is another triple. This will be 3, 4. The hypotenuse by the Pythagorean theorem would be 5. And now I can find the cosine here. So cosine of theta, cosine is adjacent over hypotenuse, so that would be -4 over 5. A lot of people that missed this here just put 4 over 5 because they didn't fix those signs right there. Now we can check it this way too. Say all seniors take calculus. So the only things that should be positive in the third quadrant would be tangent and cotangent. So cosine would definitely here be negative if we were in the third quadrant. That's another way I could get the sign if I didn't put the negatives on those two numbers. Okay, number 14, you're in the first quadrant, so it wasn't as bad there because everything is positive in the first quadrant. You don't have to worry about signs. So there's my angle in the first quadrant. I'm going to drop it down with the x-axis and form the right angle. Theta at the origin. Now, recall sine here is opposite over hypotenuse. Okay, so we're going to opposite 2 over the hypotenuse here, 5. And so we need to find that bottom leg. This is not a nice triple, so I'm going to work out here the Pythagorean theorem. It'll be a squared plus 2 squared, which is 4, equals 5 squared, which is 25. Now let's solve for it here. I'm going to subtract 4 from both sides. It's going to give me 21. So I'll take the square root now. So a would be equal to plus or minus the square root of 21. Now, since this is in the first quadrant, and the fact that it's going out to the right means that this would be a positive square root of 21. Now we can find the tangent ratio. Okay, tangent, remember, is opposite over adjacent. So opposite over adjacent. So tangent of theta would be 2 over the square root of 21. Again, opposite over adjacent. Now we have to rationalize it. We can't have a radical in the denominator here. So this would be 2 square roots of 21 over 21.